Welcome everybody. My name is Lukasz Medyk. I'm OSS product manager and also playing the role of business analyst. Today I have a presentation about 5G network and how it can help enhance automation at factory field level, employing ultra reliable low latency, network slicing, edge computing. In other words, or in taking a little bit more ambitious point of view, how 5G can become a really transformative technology for digitalizing economy, enhancing automation within industry, or simply speaking, how to implement Industry 4.0 revolution. Before I jump into the details of my presentation, let me outline the agenda. First, I will provide very short introduction to 5G. Then I would say how 5G can be an enabler for IoT systems, especially operating at factory field level. Then I will describe some challenges for communication service providers. And finally, how these challenges can be overcome so communication service providers can take new benefits, new revenue source from this concept. So a very short introduction to 5G is that 5G is probably the first specification of the network which is designed more for enterprises than for massive mass market customers. It defines three main type of services. Only first one could be understood as just faster internet, which is enhanced mobile broadband. The second one is massive machine type communication. The third one is ultra reliable low latency communication. I will focus mostly on ultra reliable low latency communication because this type of communication is designed for enabling implementation automation within the factories operating at real time, which requires low latency, reliability, and operation within real time. And the second aspect of 5G is introduction of the network slices. What is it? We might say that different industry verticals usually tend to have completely different requirements towards the network. Trying to build the network which fits into all these requirements, which are quite often contradicting each other, is very difficult. On the other hand, building separate, completely different networks for different verticals would simply too expensive. So network slicing is to combine with all concepts. So means that you create dedicated networks for different verticals instead of one network. But these dedicated networks are created by software running on the same shared physical infrastructure, so you can avoid investing into dedicated networks from physical infrastructure point of view. Next thing which I would like to outline is the role of 5G in respect to IoT. Someone might say that IoT exists and it does not need a 5G network, so why we are talking about 5G as an enabler here? To explain that, it's worth depicting the so-called automation pyramid for factories, which defines at the bottom the layers which operates below second, millisecond, and even microseconds, which is so-called factory field level. Above it are higher level systems like monitoring and supervision, manufacturing operations with manufacturing execution systems, and on the top, business planning and logistics with, for example, ERP system. The traditional, I would say, traditional IoT operates above factory field level. The reason for that is that simply prior to 5G, the wireless technology could not meet stringent requirements of factory field in respect to reliability, but also to low latency and consistent low latency to enable real-time processing of sensor data and driving the actuators to perform some automation task. So we might say that the current prior to 5G, the factory field level is dominated by wire domain. For example, systems like PLC, which is programmable logic controllers, are connected with sensor and actuated by wires. And this is the heart of automation at factory field level. The 5G network has a potential to change that situation. Of course, 5G still can be used for application for, let's call it, traditional IoT, and thanks to massive machine type of communication, it can provide the scalability of such solutions at better costs, at lower costs. Someone may argue that it is not very transformative because, as I said earlier, IoT prior to 5G existed and they work fine in many use cases. But what is really transformative is 5G ultra reliable, low latency with network slicing and mobile edge computing, as it can revolutionize the factory field level and create PLCs as a software solution. So we know that that 5G can do it and replace wires in factory field level. Someone might ask, okay, but what for you should do it when wires work quite well, and why to experiment? I think there are three main reasons, and I would start from maybe not the obvious one. So before I say what's the benefit of getting rid of wires, I would say that thanks to softwareization of PLC, which is related to edge computing, which enables 5G, the systems for automation within factory can be enhanced by application of the cloud native technology, which has huge potential of more intelligent system. And what is even more important, it offers much broader ecosystem of developers who provide the smart solutions for the factories. It's due to the fact that traditional proprietary PLCs were programmed using some legacy technology like ladder logic, which only few engineers on the market could provide. Of course, this cloud computing is not at the cost of reliability and low latency, thanks to 5G. So ultra reliable low latency guarantees that these cloud native applications not only run on the cloud, but also can operate at real-time regime. Last but not least, is getting rid of wires, of course, it's also important. For more obvious use cases would be application of mobile robots, drones, even for traditional assembly lines, which are relatively static. Reducing number of wires helps increase your agility, and which is needed when you need to reconfigure the network to adjust it to your business needs, and you need to change your factory arrangement. So once we know what benefits it can bring, the question is who is going to provide that value to the industry. And the light reading survey done between operators gives an answer that communication service providers, telco operators, has quite high expectations. The answer here says that 41% answered that we lead engagement with the industry. So telcos has ambitions not be a real enabler and probably expects to get revenue out of this business. Of course, it might not be that easy. So what are the challenges? Of course, first one is that industry will not buy 5G just for the sake of 5G. So telco operators need to learn how to sell 5G, rather in the way providing the benefits for the industry, rather to emphasizing the traits of the network. Second issue is related to that traditional automation specialists say that telco maybe are expert in managing the network, but managing the factory field is a different story. Another challenge is that concept of private 5G in the form of isolated networks still exists, and someone might say that for that we don't need communication service providers. We can build the private 5G by our own, or by partnering with equipment vendor rather than with communication service providers, building and then managing. So operators need to fight for their role, place in this new business. So what could be the answer? I think that from technology perspective, the network slicing could be a powerful tool which operators can use. But from business perspective, the first question is whom the solution should be targeted to. The most obvious one which comes to the mind is that big factories like from automotive industry are the primary target. In fact, for communication service providers, the small business could be even more attractive in the sense that small business cannot afford to buy dedicated solutions. They expect cheap solution which can grow with their business rather than requiring huge upfront costs. So maybe communication service providers leveraging the network slices can be a real enabler for that. Let me explain that. So here I'm presenting the more detailed use case where small business can operate in the form where they hire the space inside a factory. So in a single factory, you can have more than one small businesses, each of them having as if their own private factory inside such area, and they can be operated and they can be served by the shared infrastructure. Here you can see that both from one perspective, and each of the small businesses has their own dedicated slice. And what is important, on demand, the new small business can have their own private 5G instantiated on demand without requiring huge investment into the dedicated physical infrastructure. What is important, you can on demand create a network slice from radio resource perspective. You can leverage KS massive MIMO technology, so a new small business can share the same frequency in time and dimension thanks to physical separation from the other small businesses operating on the same shared area. And of course, it's not only the slicing is not only about the radio access network, but also on the core, and finally having its own automation systems, which can be quite specific to the new small business who hires the new space in the factory. Okay, so if we think that small business could be a primary target, the important fact is that there are many more small businesses than big factories, but they are smaller than big factories, which means that you need to have automation in delivering automation to these businesses to avoid the situation that communication service providers would need to hire a lot of manpower to be able to design solutions for each individual small business, as it would not scale from cost perspective. So the intent-driven automation is the concept of delivering such solutions without suffering huge cost of manpower. Intent-driven here means that the clue here is to avoid the situation that or expectations that small business would order the network slices because they don't know anything about network slicing or 5G networks. They would probably order from perspective of vertical needs, and we can call it the highest level intent is a vertical needs, which needs to be translated to the network needs. Let me explain in more details. First, I would outline the use case. Here, the simplified scenario assumes the single factory. Of course, the single factory could be a factory inside the factory, as I described earlier. And the smallest unit of concern would be a closed-loop control subsystem. Here, simplifying assembly line with video camera, a sensor, and robot arm, and software-based automation logic, which is hosted at the edge, which based on images captured by the video camera can identify 40 products and automatically remove the products which don't meet the quality of service inspection. Maybe it's simplified, but it's quite, I think, a representative use case, because you can imagine that even small business can have more than one assembly lines, or assembly line could have a lot of sections with such closed-loop control subsystem. Of course, in bigger picture, you can say that such even small business can have more than one locations which needs to be connected, or even if they don't, apart from field level, as I mentioned, traditional IoT with ERP, for example, systems can provide the benefits, but this kind of system don't need to run on the edge cloud. They can reside in traditional data centers in the cloud and provide the view more from business perspective than controlling directly the automation in the field factory. But going back to the factory floor, you can say that we have a gap between vertical layer, which defines the needs from vertical needs, and underneath you have sometimes quite complicated network. Here, this is an example of Open RAN based solutions where most of the network functions are virtualized and are hosted together with vertical specific application on the same physical hardware. Intent-driven orchestration means that I, as a customer, I don't order the network slices. I just order what I need for my factory. So the basic unit of order would be a control flow subsystems where I define, simplifying how many assembly lines I need to be instrumented with automation. And that's all what I should be able to define in the sense that I don't define what network I need for that. Intent-driven orchestration is to be able to first capture such an order by a portal of the customers. So there's no need for any workforce from communication service providers here. So automation from during the order capture, but even more important, the automation during the fulfilling the order. So this order is be automatically based on intent-driven concept translated to the requirements of the network. And here the APIs expressed by the vertical can be translated to more network-specific requirements. Here, 5 QIs could be a good example of bridging the between vertical defined KPIs and the network ones, for example, defining the GDR requirement of the sensors. And going even further, that requirements of the networks needs to be translated to how to instantiate network slices with all the network functions, with all the needed capacity, fulfill what has been ordered by a vertical. So here we can drill down even further and have KPIs defined for the network, for example, what is the latency introduced between distribution unit and the cell, and how it contributes to end-to-end delay. Of course, also RAM, CPU related to virtualization technology. As I mentioned, intent-driven orchestration is to do it automatically by translating the customer order to more technical orders, which are responsible for this translation using resource catalog and service catalog and the concept of network templating to avoid the need for network engineers to do manually. So finally, we can have a design which can be captured in a network inventory and service inventory system, which then that kind of design is instantiated via orchestration into the network. So finally, when it's instantiated, it can be then operated and basic APIs can be monitored. And from operator's perspective, large scale, meaning that many verticals, many small businesses, you can get this data and learn the verticals even better. So to improve the automation during the process of automatically delivering the solution. And of course, as a traditional IoT platforms needs to be orchestrated from my perspective, the created solution is materialized in the form of the things which are defined and higher level KPIs, like for example, speed of the assembly line, of the number of 40 products hours identified, feed back a higher level of automation systems like manufacturing execution system or ERP to have also the business view on how the factories operate. That's all from my side. Thank you for your attention.